Hello everyone, I am Emir and this is my EE102 project. In this project, I try to comment on the conductivities of the materials, and for convenience and easiness, I'll be strictly adhering to wires, as you can see here. Well, without further ado, I'd like to show you the setup I have designed here. The design I have made is not necessarily complex, and let me just go over it briefly. Ignore these two sensors. I have two sensors. These are namely, first one is ultrasound sensor that basically measures the distance between an object in front of it and itself. And I have another sensor that's magnetic Hall sensor. How it works is basically it produces a voltage proportional to the magnetic field strength it's in. The output of the Hall sensor is here connected to a voltage divider, and it's then connected to XADC input of the basis 3. I have a voltage divider because basis 3 XADC input only gets voltage between 0 and 1, and the others are connected to the JA inputs here. I also have another coil-like wire here, and this is the show you, and this is connected to signal generator here. So that I'll be generating magnetic field. Now, how it works is the working principle is that it actually based upon Ampere's law. What Ampere's law states is that a current going through a wire will produce a magnetic field, and the magnetic field and the relationship between this magnetic field and the current can be thought of as an integral function. If we imagine an Amperian loop of a wire, let's say I have a wire here, and I'm imagining a circular loop. If you've taken Physics 102, you did examples like this. And if I know the magnetic field here, and if I know the distance here, then I'll be able to know the current, and because resistance is connected to current and resistivity is intrinsic to materials, then I'll be able to comment on conductivities. So the advantage of this circuit is that if I have a wire here, I'll be measuring the distance. I'll obtain two crucial informations that are, as I explained before, the distance and the magnetic field strength. And because I have this, I'll be able to measure the current. Just a warning here is that the Hall sensor I have doesn't directly measure magnetic field, so you have to do some experiments to find out the correlation between magnetic field and the voltage it produces. Just here, let me show you the measurements I have here. Here, the first one, I use 7-segment display and LEDs to show my outputs. The output you see here is actually the distance between my hand and the sensor here that measures the distance. Like if I'm moving my hand and displays the distance. And then the second one I have here is the magnetic field. It already measures something. It's quite noisy here on 7-segment display, even if it's not in LEDs. Like I said, I have a wire that's connected to a signal generator, and AC current goes through it. If I bring it closer to the sensor, as you see, there's an increase. But because there can be disconnections in wires, I'll have to be careful. And because, well, the magnetic field this wire produces is exceptionally low, so it's really hard to detect it. And then, like I said, because the sensor is not that sensitive, I hardly get a meaningful measurement. So these are basically my measurements. Now, in this case, you might be asking to me, we are basically measuring the resistance of a wire, which we can do simply using a multimeter. Why do we go through such hardship to do such circuitry? The advantage is here, like I said, this circuit has some advantages over using multimeters. The first one is the sensors I use here are quite cheaper than the price of a multimeter, and that's a huge advantage. And the second is, well, we are not always measuring exposed wires, namely the conductors in them. Most of the time they have protective layers like the one I have here. I just create of the enamel layer out so that I could connect the signal generator. So without this effort to disrupt the output layer, I can actually measure the conductivity, and you can actually think of it as an intro to non-destructive testing methods. You can also look at it on the internet. So guys, that's my project. Thank you for watching.